Hi, my name is Amanda McWhirt. I'm a horticulture production extension specialist with the University of Arkansas Cooperative Extension Service. We are now in the fall section of our series. Today I'm going to focus on talking about soil testing and plant tissue analysis as two tools that you can use to help manage the fertility of your blackberry planting. I'm also going to talk about fall pruning and cleanup and a few other tasks that should go on in the fall. Let's do a quick review of the life cycle of the blackberry planting as we move from the summer into the fall. One of the major events that happens in the fall is the death of the fruiting cane. So on floricane fruiting cultivars, the floricanes, after they flower and produce fruit, will senesce naturally. As these canes die, technically what you will have left then is the primocanes that emerged earlier in that season. Those primocanes are now the upcoming season's floricanes. As the floricanes start to senesce, we recommend that they be removed. This is an activity that can be done immediately after fruiting, and you don't have to wait until fall. But very often growers get busy with other tasks in the field and aren't able to remove dead floricanes until the fall or sometimes the winter. And dead floricanes are often removed during winter pruning activities. We also recommend that floricanes be removed as soon as possible to try and limit the spread of any potential diseases. During the fall, the primocanes will continue to grow and develop, and for this reason, sometimes growers apply a small amount of fertilizer early on in August to try and promote as much growth on the primocanes or the upcoming season's floricanes as they can. After we have our first hard frost or temperatures start to cool off, we will see that the leaves on the primocanes will die and fall off sometime in late fall. At this point, the plants enter dormancy. On our primocane fruiting cultivars, we're in a little bit different of a situation because remember, our primocane cultivars are the ones that produce flowers and fruit on new canes, on primocanes. So they will be flowering in the summer and then producing fruit sometime in the late summer or early fall. So during this season, we could potentially still be harvesting. However, once harvesting ends, the part of the cane that produced flowers and fruit on that primocane will still die back. There are two options for dealing with removing this dead tissue from the planting. And it will depend on whether or not a grower wishes to have a spring floricane crop or not, how this is handled. If a grower only wants to have fall primocane crops, the canes can be removed all the way back to the crown of the plant or level with the ground. This is option one, and pruning would occur in late fall or winter, and basically the grower would go in and mow all the canes to the ground. This eliminates any canes that would be held over into the following spring that would then become floricanes and that could produce a spring crop. Alternatively, if growers do want to have a spring crop, pruning will occur in late fall or winter, and they will remove the part of the cane where fruit was produced and where the cane has died. The grower will leave the part of the primocane that is still alive, and that cane will develop into a floricane in the following spring and will produce a spring crop. One of the keys to pruning in the fall or early winter on either primocane fruiting cultivars or floricane fruiting cultivars is that we don't want to leave the pruned out tissue in the field. There are several diseases and insects that can spread by leaving this material in the field. So for this reason, we recommend that it be removed and burned or disposed of somewhere outside of the field. So what are some of the other fall activities that need to be done? If you are planning to install any new plantings in the spring, you will want to prepare your plant order. Though it is important to remember that in some parts of the South, growers can establish new plantings in the fall. Weed control should be done in the fall. Again, Dr. Nilda Burgos does a nice talk on this and talks about how in the fall, weeds are starting to store carbohydrates and nutrients that they need to overwinter, and so applying herbicides during this time period can be very effective. You will again want to do your pruning activities, remove those spent floricanes, and if you have very large plantings, growers may want to start pruning their primocanes or upcoming season's floricanes in order to complete all their pruning practices before the next spring. In doing this, you will want to monitor for insects, particularly cane borers. You'll want to pull your soil sample, and I'll talk about soil sampling here in a minute, And then you'll want to order supplies for the next season and plan to attend winter grower meetings. The North American Raspberry and Blackberry Association has annual meetings in the winter. I'm going to talk about monitoring nutrients in a blackberry planting today and talk about two different ways that we can do this. One being soil sampling and the other being plant tissue nutrient sampling. Now, the reason why I'm going to suggest that these two tools be utilized by growers is that they're really great ways to check in on the status of the nutrients within your planting. And this is important because if we think about limiting nutrition to our plants, ultimately that's going to have an effect on the leaves and the growth of our canes. And if we limit how many leaves are produced or the lengths of the canes, that's going to have an effect on the different sites where flowers and fruit can ultimately be produced. In addition, once the plant starts to initiate flowers and fruit, if we're limiting any nutrients that are required for fruit production, that's going to limit both the quality of the fruit that are produced and the size. So monitoring nutrients in blackberry planting can be a really great way to try and optimize yields. Now, one way to think about this is to think about the bank of nutrients that we have out in the field. You know, we have all of these different accounts where nutrients are being stored. We have nutrients that are naturally held in the minerals of the soil. We have an account where we've been applying nutrients through fertilizer. There's nutrients held in the leaves and the canes of the actual blackberry plants, and those nutrients will later be converted into fruit, and the nutrients held in the fruit are actually going to be removed from the field, so that's a net loss of nutrients from that account every time the fruit is harvested. So we have nutrients being held in a lot of different accounts, and those different accounts are dependent on one another, where the amount of nutrients that are held in leaves and canes are dependent on the amount of nutrients held in the soil naturally and the amount of nutrients that we apply through fertilizer. And then the amount of nutrients that are in the fruit are ultimately dependent on the amount of nutrients that are held in the leaves and the canes. So there's a lot of nutrients that are moving through these different accounts, but there's actually ways that we can go in and check the balance of certain accounts through soil sampling and plant tissue nutrient sampling. Soil sampling will of course give us an idea of the nutrients being held naturally in the soil and in previously applied fertilizer. And then plant tissue nutrient sampling is a way for us to go in and check the amount of nutrients being held in the leaves and the canes, which will give us some indication of the potential for fruit production in following seasons. Because nutrients are being held in the leaves and the canes, and we conduct annual pruning practices where we remove dead canes or small canes, growers do realize that they're losing nutrients from these accounts when they remove those canes from the field. However, the amount of nutrients held in these sources is very low. And so by removing them from the field, we're not really losing a large amount of nutrients. And the potential for spreading diseases is so great that we don't recommend leaving pruned out floor canes in the field either to be mulched or to be left to decompose. Now, I do want to emphasize here that we're really testing two different things when we look at soil sampling and plant tissue nutrient sampling. In soil sampling, we're sampling what nutrients are being held in the soil and can potentially be accessed by the plant. But it's important to realize that all the nutrients held in the soil aren't equally accessible by the plant depending on how mobile they are within the soil. Nitrogen or nitrate is very mobile in the soil. It moves around quite a bit, as does boron. Some of our other major nutrients like phosphorus, potassium, calcium, and magnesium are less mobile in the soil. So it's important to realize that we need to pull soil samples from the right location close to where these nutrients can actually potentially be taken up by the plants. When we're doing plant tissue nutrient sampling, we're actually assessing what was taken up out of the soil bank into the plant. Now, it's important to remember that within the plant, nutrients can also differ in the mobility as well. So this refers to how easily can a nutrient be reallocated from one part of the plant to another part of the plant. So for instance, nitrogen, phosphorus, potassium, and magnesium can all be taken from older parts of the plant and be moved into new growing parts of the plant as they're needed. Calcium and boron are very immobile within the plant, so they cannot be reallocated. This is important for helping to identify nutrient deficiencies where the symptomology may occur in the plant. It's also important to realize that because several of these nutrients can move around in the plant, it's important that we take the plant tissue nutrient sample at the right time of year. This is because we have standards that have been established for plant tissue nutrients in Blackberry that are based on certain phenological stages of the plant. If plant tissue nutrient samples are taken outside of this standard phenological stage, it may be difficult to accurately interpret the results because of fluctuations in nutrient levels within the plant based on the season of the year. So let's first talk about plant tissue nutrient testing. So why do we sample plant tissue nutrients? The idea behind this tool is we know that we need certain amounts of nitrogen, phosphorus, potassium, calcium, and boron, and other nutrients to be held within the leaves of the plant that will later be converted into fruit. And therefore we know that if certain nutrients are low, that in some way is going to limit our fruit production in subsequent seasons. Here we have a graph that's just showing crop growth in relation to concentration of a nutrient in a diagnostic plant tissue nutrient sample. So you can see on the bottom axis we have tissue nutrient concentration on a dry basis, and then growth as percentage of the maximum growth that can be obtained. So early on you can see that when there's a deficiency of a nutrient, as we increase the amount of that nutrient that is applied, we get very strong increases in percent growth. But eventually we'll get to this transition zone where as we increase the amount of nutrients that are being applied, we get smaller amounts of increased growth. Very often growers may be in this transition zone where they think they're supplying a sufficient amount of nutrients, but they're actually not achieving 100% maximum potential growth. And so plant tissue nutrient sampling can help with this to identify what nutrients need to be supplied so that no nutrient is limiting our potential yield. Now, plant tissue nutrient sampling can also help us identify if we are over-applying certain nutrients to the point where we are wasting money by applying those nutrients and not getting any corresponding response of growth. And this is what is called luxury consumption. Plant tissue nutrient sampling can also help us identify if we're over-applying nutrients to the point where we're getting a toxicity that may develop, which will actually result in a decline in growth. Plant tissue nutrient sampling can be used in two different ways. One is a predictive analysis, and this is sort of like when you go to the doctor for a checkup. You're not sick, you're just going to try and identify any issues early on and prevent them from becoming a real illness. Predictive analysis is used to estimate fertilizer rates for the following year. The idea is again to detect issues before they appear. This type of analysis is going to be done after fruiting in the southeast, and I'll talk about the specifics of that a little bit more, but you'll be sending in a normal sample. Diagnostic plant tissue nutrient analysis can be used when you're already recognizing a potential nutrient issue. And this is like when you go to the doctor and already have a cold or a cough. This can be done any time of the year, and the way that it is done is to send in both normal samples and then send in a sample from plants where there is a suspected nutrient issue. The two samples that can then be compared to try and identify what potential nutrient issues may be going on. Some symptoms of what deficiencies or imbalances may look like is changes in leaf size or shape, changes in leaf color, changes in overall growth of the plant or the plant vigor, reduced yields or changes in fruit quality. This may mean smaller berries or berries that are misshapen. And one of the ways that we can identify deficiencies is to think about, is the nutrient mobile in the plant? If the nutrient is mobile, we're going to want to try and look for these types of symptoms in the old leaves, because the nutrient will be reallocated from old leaves into new leaves as is needed in the growing points of the plant. If the nutrient is not mobile in the plant, deficiencies will show up on the new leaves, because as the plant continues to grow and that nutrient is not present in adequate amounts, the symptoms will appear on new developing parts of the plant. Some examples of this with nitrogen: if there's not enough nitrogen, some potential symptoms you may see are low numbers of canes or low cane vigor. chlorosis or yellowing of the old leaves. Nitrogen, again, is a nutrient that is mobile in the plant, so we're going to look for deficiencies on the old leaves. You may also see small berries or overall low yields. If you are over applying nitrogen, you may see long lengths between the nodes or a long internode length, which will result in lower yield per cane. You may have reduced fruit firmness or shorter shelf lives. High nitrogen applications can increase the risk for disease. And if you apply nitrogen too late on in the season, canes won't acclimate and you'll have a greater increased risk of winter injury. So how do we plant tissue nutrient sample blackberries? Again, the when and the how is going to be very important because the standards that we use to interpret blackberry plant tissue nutrient samples have been established for certain plant parts at certain phenological stages. On floricane fruity varieties in the southeast, they should be plant tissue nutrient sampled after harvest. On primocane fruiting varieties, they should be plant tissue nutrient sampled at green to red fruit stage, which is generally late July or August. And so this corresponds pretty closely to when you would also be sampling your floricane fruiting varieties. In high tunnels, as Elena Garcia instructed us in her talk, they should be plant tissue nutrient sampled in late July or August, which correlates to about 10 to 20% bloom in Arkansas for primocane fruiting varieties. How do we plant tissue nutrient sample? What we're targeting here is the primocanes. The second part that's going to be important to this is that we are targeting specific leaves on the plant. And what we want to collect is the most recently mature leaf. So not the newest leaves that are emerging at the end of the primocane and not the older leaves that are beginning to age. Generally, this is a leaf that is about 4 to 5 leaves back from the growing point. And you can see in this picture on the right-hand side where we estimate that is. So you can count back about 1, 2, 3, 4, 5. You'll want to collect leaves 1 to 2 per plant from 20 to 40 plants within a uniform area. So this could be an area where you have the same variety planted, the same soil type, the same planting date, and the same management history. After leaves are collected, they should be submitted in a paper bag. It's important to remember that if there's a lot of dirt on the leaves, you'll want to brush that off, and you want the leaves to be dry when you submit them to your testing lab. University of Arkansas has a lab. Many university systems have plant tissue nutrient testing lab. You can contact your local county agent or university to find out more. So once you get the results, how do you use them? Ideally, you'll want to look at the results and then compare them to the established ranges nutrient sufficiency for blackberry. These nutrient ranges can be found in the Southeastern Regional Caneberry Production Guide, and they are listed here. If a certain nutrient is below the ideal range, that can help you identify potential nutrient deficiencies and amend your fertilizer practices for the following year. Now I'm going to move on and talk about soil sampling. So how do we pull soil samples? There's several different considerations that we want to keep in mind. Timing is very important because, again, if we want to try and compare results from year to year, we want to keep our timing consistent. And generally, fall is seen as the ideal time to pull soil samples. And this is because if we need to apply any lime to amend the soil pH, this allows for a lot of time for the lime to become activated in the soil before the plants start actively growing again in the spring. What we want to do is to get a good representative sample from an entire area. So for an acre, you would want to pull 20 to 30 samples or 20 to 30 soil cores to a depth of 12 to 16 inches and put all of those soil cores together in a bucket and mix them and then pull a subsample out of that you would submit to your laboratory. If you're just starting out in your soil sampling field prior to planting, you can pull those 20 to 30 soil cores randomly from across the entire area. If, however, you are soil sampling an established planting, you'll want to pull those soil samples from in the row close to where the roots of the plants are growing and close to where there are emitters from your irrigation line, particularly if you are applying fertilizer through fertigation. However, you don't want to pull soil samples immediately after applying fertilizer or lime. Here again, you will want to submit separate samples based on differences in soil type, management history. You can also submit diagnostic samples, again, if you're having areas where there are problems showing up, and you can submit a sample from an area where there are no problems and use those as a comparison. So how do we use our soil test results? Most university or state departments of agriculture throughout the Southeast provide some type of soil testing service. The results that you will get from your laboratory can vary quite a bit, but the two major things that most soil tests provide is information on soil pH and information on some basic nutrients. The reason why we want to look at soil pH is because soil pH has a really big impact on the availability of different nutrients within the soil. And so we want that pH to be within the range of 6.0 and 6.5. Soil test results can also help us monitor nutrients like phosphorus, potassium, and boron and amend our fertilizer applications for the coming year. Most soil test results do not provide information on nitrogen content. And this is because nitrogen can be very volatile or very mobile within the soil, and soil test results can sometimes be inaccurate and not useful in order to make recommendations for fertilizer applications in the subsequent year. Results from plant tissue nutrient testing are generally seen as a better standard to use for amending nitrogen fertilizer applications. Very often soil tests do not provide any information on soil texture, but this service can sometimes be supplied by your soil testing laboratory for an additional fee. You'll have to inquire with your specific laboratory to see if it is offered. So why is soil pH so important? The reason why soil pH is important is because different nutrients vary in their availability based on the soil pH. So if you look at this graph here, we have our macronutrients, or nutrients that are required in large amounts by the plants, on the top, and then we have our micronutrients, or nutrients that are required by the plant in smaller amounts, on the bottom. And you can see that the availability of different nutrients varies based on how thick the bar is at different pHs. So generally somewhere between 6 and 7, most nutrients have a very wide bar, meaning that they are very available to plants. You can see that once we get below 6.0, many of our nutrients that are required in large quantities start to become less available, which means that we can be applying these nutrients, but these nutrients are going to be bound up by the chemistry of the soil and not available to the plant. So we can be fighting a losing battle by applying a lot of nutrients to the soil, but because the soil pH is not within a suitable range, those nutrients will not become available to the plant. This is why soil testing should be combined with plant tissue nutrient testing. If we see that plants are deficient in certain nutrients and have amended our fertilizer applications but are not seeing associated responses in plant tissue nutrient content, there may be an issue with soil pH. And so combining soil testing with plant tissue nutrient testing can be powerful tools for monitoring the fertility of your blackberry planting. On the other hand, many of our micronutrients do become more available as that soil pH drops below 6.0. And this can become a concern because a lot of these micronutrients in too high of concentrations can actually create toxicity situations for our plants. So for this reason, we want to maintain the soil pH somewhere between 6.0 and 7.0. Now, if we think of soil pH on a region-wide basis, it's important to realize that most of the soils throughout the Southeast tend to be very acidic. And we can see that here in this diagram, where a very green color means that the soil pH is above 5.7, and very red color means the soil pH is below 4.1. You can see that throughout much of the Southeast, we tend to be on the lower end of that range towards more acidic soils. Due to this natural tendency of our soils to be on the more acidic side of the soil pH range, and the effect of a low soil pH on limiting those macronutrients, those nutrients that plants need in a large quantity, soil pH tends to be the biggest limiter of crop yields in the Southeast. And so this is an important consideration for us in managing fertility. So how do we amend the soil pH? Soil pH should be raised using limestone or lime. If a soil pH is too high, it can be amended downward using sulfur. There are a lot of different options out there for different types of lime, and I'm not going to get into that here, but it is important to realize that how we amend our soil pH is important based on when, how much we apply, how deeply we apply it, and then how often we soil test to monitor our soil pH. Fall is the optimum time of year to do this, or 6 months before planting. Again, it takes about a year for full effects to be seen for standard limestone. We want to try and amend the soil pH before we go in and plant. Amending the soil pH after plantings have been established can be very difficult because it's hard to get limestone down into the rooting zone of an established planting. Again, we want our soil pH to be between 6.0 and 6.5. It's important to remember that sandy soils need less lime, but more frequent applications than a clay or a highly organic soil, because sandy soils tend to have lower cation exchange capacities. And cation exchange just refers to the ability of the soil to hold nutrients. How deep do we want to incorporate lime? We want to incorporate it to the rooting depth, so about 12 to 16 inches. Lime does need to be tilled in. It's also important to ensure that we need to make even applications across the field. So lime should be applied in a crosshatch pattern, so you'd apply half of the amount that needs to be applied in one direction and then the other half in the opposite direction across the field. How often should you soil test in an established planting to monitor nutrients and soil pH? We generally recommend that every 3 years is sufficient, but you can test annually if you suspect a problem. Again, we recommend collecting samples from in the row at a depth of 12 to 16 inches and to not sample after recent fertilizer applications or recent lime applications. That's our quick review of soil testing and plant tissue nutrient testing. Thanks so much for watching.